All right, so here we have this is the main board of the what's it called? Of the Ford Fusion inverter. This is the same inverter they use. I believe since 2013 to 2020 or 2019. Regardless, the only like teardown I've seen of this is by Weber Auto, so I figured why not try to do something with it. Um, so here we have, I'm just gonna put this, in big red letters and say it out loud. I am very amateur, with all of this stuff. I dabble basically, so don't think I'm some sort of, electrical engineer. I'm nowhere close to that. But, anyways, uh my findings. First of all, this board, I believe the entire assembly is made by Toshiba. I'm not sure if this board says Toshiba anywhere, but the other boards do. And the modules, the IGBTs, I don't have a picture of them right now to show you, but they're also made by Toshiba and they're, proprietary parts. There's no data sheets anywhere I could find. But anyways, this is what I've been able to find. First of all, the engineers that designed this, they did an extremely good job at labeling everything. It's like just the complete opposite of Tesla, right? Everything, man. Like here you have this. It tells you, right? They use G for one electric motor and M for the other. I believe it's generator and motor. Sort of like, in the Prius you have MG1 and MG2. Well, you have M and you have G. That's how they differentiate them. So it tells you, oh, this is a PWM for, instead of using U, V, and W, they use A, B, and C, right? So you have, they mark it B. So where's B? B is right here. It's this row, right? So you have um the IGBT, right? The high IGBT of motor, phase B of motor G is controlled by this. It comes right out of this thing, right? And MPC 5565 MVZ 132. I have no idea what it is, and I don't care, to be honest. Um, but yes, see, you have all 12 PWM outputs, right? And then you also have VVC, right? Which now, in hindsight, I imagine it's a variable voltage control, maybe, right? But this is a boost converter, and right. So you have this chip controls all of that, okay? And now at idle, to be able to get this the board to power up, it's not as simple. If you look up the wiring diagrams, which I'll post them in the forum. But once you get the board running, you'll see that this thing right here outputs. Uh, it wants to turn all the high gates on, right? So you'll see A, for example, this row here. This is low, so this stays low, but this is gonna be at 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, and 0 volts. And but you'll see out over here, which is also, I don't have a picture of it once again, but if you take off this connector, it shows you the basically what each of these pins are. Now I know that they're in pairs, so like this is the upper IGBT and this is the lower, upper, lower. So this is one module, right? And this is another, and this is another. Now these modules are actually four IGBTs in one, so these might be one module. I'm not sure. I haven't tested that enough. I don't have the stuff here with me to do it. But you'll see, right? All of these are when the board is power on. All of these are sorry, they are at 160 millivolts, like almost exactly. And of course they're off. And you'll ask, well, damn, like where's why like if this is trying to turn them on, why are they off? So I figured this, this EN GIPU, this pin right here to this test point. I tried putting 3.3 volts or 5 volts, uh, whichever works. Um, this activates these. I believe these are. I don't know if they're optocouplers or repeater. I don't know, or like AND gates maybe. I don't know. But when you put 5 volts on here, the signals that are coming out from here go through here and they go into the driver board, which is if I flip over, right? It's they go in through this cable, which is this cable that comes out of here, and in here, and you can also drive the gates from here. But I figured, but this is a lot more uncomfortable than this, of course, because this is you have everything right here. Now, when you do activate enable GIPU, for example, this is a G, right? This is a generator, so it's gonna only gonna be controlling three, of the six phases you have. Now there's another pin here. Well, there's two. There's enable VVC, which I'll get to that later, and there's enable where is it? Yeah, MIPU, which is the same but for the other three IGBTs. So when you enable this, you'll see that this right, this IGBT here, this half bridge, let's call it, this is gonna be pulled high, and it's gonna start conducting, right? And this is gonna be pulled even lower because, like I said, at idle they're at 160 milliamps, millivolts. Sorry, all of them. They're just sitting there, and when you enable it, right, that the signals from here, which is high, which is your 0 volts, 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, they come over here through, I believe, I imagine, I'm not sure actually if it's a direct connection to this IC, but or if it goes through a couple of things here, but regardless, it gets here and it pulls this down, from 160 millivolts to zero, or very close to zero, and it pulls this to like 4.9, 4.8 around there. But testing it, I, hooking up 5 volts through a milliamp meter, just driving it, right? Leaving all of this untouched, you can, turn on the high gate, just put it there, and it draws like 7 milliamps. So this is very, easy. You can drive this with a. I'm not sure what an Arduino can do, but I know an ESP32 can do like at least like 12, 13 milliamps per IO port. Correct me if I'm wrong. I believe it's somewhere around there. There's more. I'm almost certain it's more than the 7 milliamps it takes to drive this. Now, my mistake. I blew up my boost converter IGBT. Now, why it was so easy for me to blow it up, I have no idea. I don't know if this is like maybe they're not IGBTs, maybe they're like some weird, like silicon carbide or something, because I'm using my 12-volt lab power supply, that can only put out 10 amps. So, and it blew up, right? and I tested it was just dead shorted, right? There's no doubt about it. Uh, but anyways, the way I killed it, just so that you know, so that you don't blow it up yourself, is I figured that these, right, VVC, because I was looking, right, because the gates were easy because it's kind of like obvious when you have 12, things, 12 pads right next to each other. It's like, yeah, those are your 12 gates. But the boost converter, right, you have two gates, I presume. I hope there's only two gates because I've only been able to find two. But, what's it called? This was more difficult. So I was, probing around, just putting, basically measuring with my multimeter, making sure that there wasn't, 12 volts or higher or anything. Just making sure that everything had, 0 volts. And I tested these, with respect to ground, of course. And they were measuring 160 milliamps as well, just like these. So I figured, well, these are gonna be the boost converter, high and low. Well, they are. But for some reason, I'm not sure if when I was probing, maybe I turned them both on at the same time. If I use like if my lead was too big and I slipped between them, maybe that could have been what happened, right? It is entirely possible, and I mean, it's probably the most likely explanation, of course. Now, what? So, sorry about that. This is right under. You see the same connectors here. This is the boost converter, buck converter section. You have your capacitor. You have your inductor, right? This is a positive input. It goes to a connector on the outside, and this is a negative, right? You'll see the positive goes straight through the inductor, goes through here, and it goes into the center pin of the half bridge of this module. And the negative, it's a common negative, so it goes here, goes to the negative of this module, and it goes straight down into the other, I believe it goes up here and over here and, you know, over there, whatever. Anyways, so what happens? It's like the Prius inverter, right? It's pretty much the same topology. So if you wanna put your voltage here, your power through here, right now, if I wanted to put, my 12 volts that I'm testing with, well, I can't because I don't have an IGBT anymore, right? But if you did, and yours was working fine, you put your 12 volts and your negative here, or whatever, your battery. And your 12 volts is gonna go, and it's gonna go here, and it's just gonna stay there. Why? Because the IGBT is off, right? Like I said, these no, it's not here. These right, these test points are the gate drives outputs, and they're both pulled low. So what happened? Like I said it before, the EN VVC, this pin right here, when you um pull this high, right, when you put 3.3 or 5 volts into it, uh the high side of the IGBT gets pulled high and the low side gets pulled low. So what happens? Um right, this means that your the middle of the half bridge is going to be, you're switching basically the high side, right? So it's going to pull to the positive, and you're going to basically just use the this IGBT is a basic switch, right? You're not boosting, you're not doing anything, you're just using it like a pass through, right? Now, to buck, or not, sorry, not to buck, to boost, that is where I have not figured out yet, and I'm not gonna be able to figure it out because I blew up my IGBT, right? So I can't test it anymore. But I presume, I mean, boost converters, the way they work, you leave the high gate alone, and you just you use a very low percentage duty cycle. You pull your low to ground. So actually, what happened to my IGBT was that the low side got shorted out. So what happens, right? You see here, the current goes through here, right? Your inductor is just at positive, right? So what happens if your low side is shorted out? You're gonna short it through negative. So all your power is just going through the inductor, and you're just shorting out the inductor, right? So the way a boost converter works is you just short out the inductor for a split second, a very very small amount of time, and when you open the switch, right, it has a voltage spike, which then goes through the diode of the high side, and it charges. It goes out, and this is a positive, right? The high voltage bus. This is your battery bus, which is it's also high voltage. It's like 240 volts, I believe, on the Fusion. Um, but it's not as high as the 600 volts you can use. Which again, it goes over here, and then you have your capacitor, which covers basically all of this stuff. But anyways, this is as far as I can get. Unfortunately, I it sucks because now I don't know if it was my just a stupid mistake, right? That I just kind of shorted out between these two, or if there was something more going on, right? So I can't tell you just if you wanna drive the boost converter, just use right, just pulls this gate and you can drive it. Now, there's other things on this board which are useful, right? This is a Hall current sensor. This one right here. This this measures basically the current out input from the battery, right? The current input going through here. Now, if you put your power from the outside, let's say from you put your power directly here, you're not gonna be able to use this. But this is just a basic, zero. I believe these two are negative. This is positive, and this is your output, and it outputs 2.5 volts, and then if your current is positive, it goes up. If it's negative, it goes down. But this is very easy to test. With an adjustable power supply, for example, you can just note down. It goes up however many millivolts per amp or whatever. This connector, I don't remember. All right, this. Okay, yeah, this is what's it called? The pyro? No, not the pyro. The This is basically the disable. There's a cap on the underside, or no, right here. Right, you see this cap? This cover. You pull it out and it disables the inverter, right? It basically removes the bridge from this, I guess, so that the inverter doesn't move and doesn't run, I guess. Now, I don't think it matters for us. I tested. I've been able to run this board with everything unplugged except this one. Well, and the boost converter, of course, if you're gonna use it. Now, the thing is about the boost converter, why I'm uh what's it called? Sorry. The thing about the boost converter that I'm not very um happy about, right, is that for the other IGBTs, you have this big board and everything is labeled right here, right? You have your gate. See, on this side they call it XYZ. On the other side, they They use, ABC or whatever. But anyways, they label everything and it's very easy to see what's going on. But on this, on the right above this module, right, there is another board which has a little transformer. It's maybe half the size of this one. And a whole other driving system. And there's only maybe like a couple test points, and they're not labeled well. I don't know if it was made by a different person because if you compare it to these, it's right. This tells you everything you need to know, pretty much. At least to drive it. The boost converter, I tried, I looked, and I was like, whatever. That's why I started probing, and that's why, you know, I kind of stubbed my toe there a little bit. But anyways, um, anything else on this board? Yeah, these are the current sensors. So you have the three phases. I don't know why they're different because they have the same plug. Each of them has 5 plugs, right? Positive, negative, and then you have your three, one for each phase. The same with this, one for each phase. I imagine they're different because so interchange them, right? But this is for one motor and this is for the other. This is a thermistor for let's see, right? It goes here and it just goes into in between the butt of the inductor. What else on this board? This board is honestly, I didn't really look much at it because now I wasn't able. I did try to get it to run without the other board, without the main board, but there's some signal somewhere, right? And this is a huge connector. This is I don't know how many pins this is, but it's a lot. And I don't have the patience for that. But I tried because these capacitors, they get, your same 12 volts as what's it called? I'm sorry. As the rest of the board, right? This has its own power supplies and everything. But for some reason, if I just charge, if I put my 12 volts here, it does draw power. It draws, I believe, like 30 not 30, 300 milliamps, right? So 0.3 amps. And it does, something. But I was not able to drive the gates. So I believe, there's something, maybe there's like pull ups, pull downs, or there's something on the other board that, makes it behave properly, of course. Because it wasn't, without the other board, like as it is right now, right, assembled. You just put your 12 volts, and all of these are going to be pulled down, obviously, at 160 millivolts, right? You put you put 3.3 volts here. You're gonna turn on PGX, which is this corner right here of this IGBT. Now PGY is this IGBT, right? So it's the bottom left of each IGBT. So PGX, PGY, PGZ. Now these three here, this one, yeah, this one, and this one are the top right. So it's right here. So and the one thing of all of these that I was able to find the switches is are the ones that end with G. So mug is this second. So it's the first pin of the connectors, right? Or the end pins. Let's call it that way. Let's put it that way. Right. So this bottom one switches this gate on. This one switches this one on. This one switches this one on, and then on the other side, of the board. Though I think under the connector there's also some test points, but I mean those are kind of worthless because you can't do anything while the connector's there, and it doesn't work without the connector. Unless, again, maybe there's some voltages that you have to put in from the outside that, to get it to run. I imagine that's what happens, but I was not able, I tried with a battery, a couple things, and honestly, I wasn't able to get it working. But, anyways, um, this is kind of, again, a very amateur perspective. I know very little about most of this stuff. I do know a bit, not enough, to be able to understand why there's so many different things to this, right? If you're just switching a gate on and off. Um, anyways, this doesn't have much to it. The IGBTs have even more ICs in there. I have no idea what they do or how they work, but fortunately, I don't need to because um, you can switch them from the outside, right? What else? Yeah, so the boost converter, I already went over that. Um, but yeah, I don't know what much else to go over. This, this connector right here, I believe, or sorry, not this connector, this chip, right? This microcontroller. I believe, right? So you have these pins that are near it. Um, this is like current. I believe this measures this basically, the hall sensor current, maybe, right? Because but then you have like econ mode. What does that even mean? I don't know, but I tried messing with all of these. Some of them are already pulled high, some of them are pulled low. PWM I believe that's a monitor. I wasn't able to get any of these to do anything, right? But like I was saying, the Toshiba engineers really, they labeled everything. You see J here, you're thinking like, oh, what the hell are those? They're right up here. HMDI run SD2 wake up, whatever. Engage clock, maybe. If you know what that chip is, maybe this is useful for you, right? Um, these connections right here, they're these, right? This is C. These are current measurement for. I don't know what. This is a lot of information here, and I don't know much about it, so I'm not gonna really go into it. But once again, what I did figure out was that just leaving these as they are, right? You have to have the board in place. You can just put, I imagine you can put like an SMD header, right? If you find, you know, two 6-pin, connectors that are, SMDs, and they're, I don't know if this is a standard spacing, maybe. Actually, probably not. But you might get away with it actually, just have to measure it. But, if all you want to do is run the gates. Now, to get rid of this board, I am not knowledgeable enough to figure that out, unfortunately. But I do know, if you want to, in my case, I was thinking maybe I could use this as a golf cart controller. Basically, all I would have to do is, ignore the low gates, just put all the high gates together and drive them in parallel. and just use it as a a PWM controller. So I would just have that, and I would get the 2.5 volt output from the current sensor. I would have to put it either through, if I'm using a 3.3 volt IC, something, voltage divider, or I could, if you want to do it right, use, like an ADS 115 or whatever that can handle more a higher voltage. Um, because if you're using something like an ESP32, the ADC in the ESP32 is not the best. But anyways, anything else about this board? This is just, I guess, power supplies right here with these big inductors. Um, I don't know what that is. I imagine it's a controller for the power supply. This is a CAN section. You see, right? Because this goes to the motors, right? This connector here is the one that, the resolvers, the temperature sensors. I imagine there's a couple in there. This is your main, your harness that goes to the rest of the car. So your CAN goes through here. Your 12 volts go through here. Most of everything is happening here. You know, this is just the motor, encoder positioning and all that stuff. But anyways, you have this stuff. Again, I have know very little about this. I just know one of these is for one motor and one of these is for the other. I believe they're the same. You have the same, the same exact chips. It's just like a clone of each other, but they're moved around a little. This says COS MGNT, no, MNT M, right, and this is sine G. So cos G, right? So you have cos sine. Maybe like I imagine it has something to do with trigonometry. I hate trigonometry, so I'm not gonna think much about it. But um, yeah. I mean, I don't know what There's so many labels, right? There's half of this board is test points if you look at it. But anyways, that was just basically if anyone was interested in this. Um, I don't know if I'm gonna do anything with it. Maybe. We'll see.